Hello friends. So today we are going to take on the subject of intervals. Now intervals are quite an interesting topic for an interview because you can actually do 2 to 3 interval questions in one single round of interview. So on top of that, interval questions are very synonymous with the real life problems. So real life problems such as like interval management, calendar management, scheduling, availability zones. So all of these things, they are closely related with the concept of intervals and their implementation. So that's why interviewers love asking this question. And today I'm going to show you 6 most popular interval questions. And trust me, doing these questions would actually cover all the interval topics. And you really wants to be prepared for that, because me personally, I got asked interval questions in my DoorDash interview and also in an interview with a smaller company. So you can imagine that these interviews are pretty rigorous and pretty popular, and hope you find it useful. Okay, now let's just quickly go through this remove interval problem. This is a LeetCode 1272 number problem, and this is actually a LeetCode premium problem. So that is why I decided to solve this problem, because I know not many people can afford the LeetCode premium subscription, and since I already have it, I want to make the most use out of it. This is a LeetCode medium problem, and in this problem, basically, if you want, you can read this whole statement, but I'm just going to explain you that what it is asking us to solve. We are simply given an array of intervals that defines some intervals that we are already given, and these are already non-overlapping intervals. That is good in our favor. We are also given a new interval that we need to remove, which means if we remove this new interval, all the intervals that it overlaps, they needs to be removed from this original input list, and then we only need to return a new list of arrays or new array list that contains all the intervals that are not part of this to be removed part, and that is the answer we need to return. So let's just try to understand this with an example. Suppose again, just like this, we are given an interval that looks like this, and let's just give values 1 3 and then 5 7 and then 9 11. Okay, and then we are being asked to remove an interval that looks like this one. The value is 2 2, let's just say 6. Okay, this is what we need to remove, which means we can still keep this portion, but we cannot keep this portion. This we will have to get rid of, and even until this portion, everything needs to be getting rid of, but this portion we can still keep. So the answer in this case is going to be that first we will have an interval bit that is 1 to 2, then we won't have any interval until the value 6, but after the value 6 there exists an interval between values 6 and 7. So again, between 6 to 7 there is going to be a new interval, and then this 9 to 11 is going to left untouched because it was not part of this 6 to 11. So what the simplest solution we can do is, and in my opinion this should have been a LeetCode easy problem, not medium problem, but anyways, LeetCode has their own ways to decide. What we can simply do is, whenever we are given an input and we are also given the interval we are trying to remove, so if we just take a look at the same example again, basically what we can do is that simply we can check for every single interval that we iterate over to see whether it conflicts with this new interval that we are trying to get rid of. So in the first place we check, okay, this value is 1 2 3, and the value that we are trying to get rid of starts at value number 3, which means that there exists an overlap between these two intervals. So because there exists an overlap, we will have to do something, and what we are going to do is we are only going to pick the values between this 1 and 2. So between these two starting values, we are going to create a new interval and store it in our answer. So 1 to 2 is going to be the new interval. Then this part we don't care. Okay, now we are on the next interval. Again, for the next interval, we are going to check that does its ending value is greater than the ending value of the part we are trying to remove. If that is the case, which means there is a possibility that this interval will have some value that we can add in the answer. Suppose over here, if we had one more interval that looks like this, okay, I'm just giving you an example, then this interval has to be removed completely because both of their starting and ending value falls between these two portions. So then we can't do anything in this case, which means that this interval is no use for us, so we will simply skip to the next one. But in this case, since this interval already has a value that is greater than the ending value of the part we are trying to get rid of, so then the value difference between the part we are trying to get rid of and the ending of this current variable, so that is 6 to 7, that would be stored in our answer. So 6 and 7 would be stored, and then all the other values, so in this case 9 and 11, will be left untouched, and we can add it to the answer. And this is the whole solution. Now if we see time complexity, in this case the time complexity is simply going to be big O of n, because we might have to iterate over every single value inside the given input. And in terms of space complexity, well, this is debatable. You can argue with your interviewer, since in this case we are explicitly told to create a new list and return that. We are just simply creating a new array list, and then we are adding all the solutions to that. So in this case, we can mark the space complexity as constant. But if we are not being asked and still you are using a new array list, then it could be considered as big O of n. So you can discuss with your interviewer on how you want to treat the space complexity as. And this is the whole solution. Now let's move. I'll just show you the coding part for this remove interval problem. Okay, so for the coding solution for this remove interval part, this is the input we are given. Basically, we are given the set of intervals, and we are also given a new interval that needs to be removed. First, we are going to initialize a new list where we are going to store the result that does not contain any interval that is to be removed. Then we are going to iterate over the given input of intervals. First, we are going to check that if we find all the intervals that does not have any sort of overlap before this to be removed and after this to be removed, we can simply add it to our this new result list we created as it is. No issues with that. However, if we find that there exists an overlap, in that case, we will have to pick the smaller portion. So between the starting values, we are going to pick we are going to create a new interval that is made out of the beginning values of these two interval values. And even for the ending portion, we are again going to repeat the same process that to find the interval that is made out of the two ending values difference, nothing more than that. And after that, after this loop ends, basically we would have our result populated inside this new list we have created, and we can simply return that. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently in terms of time and space complexity. So you can see how interval problems are behaving. I just showed you this solution because I haven't solved this before, and I just thought that you at least get some idea on how these interval items are being done.
Hello friends, we are still not employed by a FAANG company, so let's not stop LeetCode until we get there. Today we are going to do a very interesting LeetCode problem, interest interval. And if you see the number of companies that have asked this question, it's really amazing. The companies like Google, LinkedIn, Amazon, Robinhood, Facebook, Uber, Apple, Twitter, Microsoft, ServiceNow, Bloomberg, and Goldman Sachs. Like these are, if you see the description of my channel, these are my dream companies that I want to get a job of. So that's why I'm doing these questions and I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and essentially we are given an array of non-overlapping intervals. This is a multi-dimensional array. It's a 2D array, and at any given cell, essentially we are given the value like start and end, which indicates that there exists an interval between those times. Now our aim is that we need to insert a new interval into the list, into the array of intervals that we are already given, and we need to maintain this non-overlapping quality of the intervals. So if we try to understand this with an example, suppose over here we are given a set of intervals like 1, 3, 6, 9. So we are given an interval like this 1, 2, 3. This is already given, and we are also given another interval like 6 to 9. And we need to insert a new interval called 2 to 5. So if I draw it on paper, it would be something like this. So 2 would fall over here and 5 would fall over here. And this is the new interval that we are trying to insert in this original existing interval. So how can we insert this new interval? Well, the answer is actually simple. Essentially what we are going to create a new interval is that we will start an interval at position number 1. Then from 1 we will have an interval all the way up until the position number 5, and then we will have another interval from position number 6 and all the way to position number 9, and this would be the two intervals that we will have to take care of. Now the thing is, in this problem we can clearly identify that why did we come up with this approach, because we wanted to make sure that we do not have any overlapping intervals. So that is why when we found out that this is the existing interval and this is the new interval that we are trying to achieve, if we wanted to insert this one, there exists an overlap between these positions, between this 2 and 3. So that's why, because there was an overlap, we actually chose to merge these two intervals and we created a new interval like this. And for this one, this had no concern with the existing with the coming of new interval, so that's why we left it as it is. So let's see that what could be the different approaches we can take, what could be the different scenarios, and how we need to behave in any single scenario of them. And essentially that would be our solution. So first of all, if suppose we are given a number series like this, and we are given a list of intervals like this, that there exists an interval between this value 2 to 4, there exists another interval between this value 8 to 10, and 13 to 15. Now let's see that where different set of intervals can be entered. So suppose first of all we are given an interval like this that is not overlapping with, or that is not in conflict with any existing interval. So let's see that what would be the scenario in that case. Suppose we are given an interval like this, that from 0 to 1 we are given an interval like this. Now if we see this new interval, it has no sort of conflict with any of the existing intervals. If we wanted to add this to our array of intervals, it would be just pretty simple. We simply create a new interval like this, 0 to 1, and then return whatever all these values are, and this would be our answer. So we would be done in this case. There won't be any issue. But suppose if this is not at the first or at the beginning of the intervals, if this is at the end of an interval, so suppose this particular new interval that we are trying to enter, suppose we are given some interval like this, that from 16 to 17 we are given an interval. So suppose we are given an interval from 16 to 17, something like this. Now in this case, what would be the approach? Essentially we would be doing the same thing. What we would be doing is we would be transferring this interval on top of whatever the existing intervals we got. And how we are going to do it, basically we are going to start traversing towards the original given input. We are going to see that, okay, where is the starting point of this new interval, and where this new interval can fit inside the existing set of intervals that we have. Now in order to check that, essentially what would be helpful? It would be helpful if we had a sorted set of intervals, and in this scenario all the intervals that we are given, they are already sorted. So that is why which works in our favor. So which means it becomes really easy for understand that where this new interval we wanted to shift into. And in this case, so we will start traversing. We will first see that, okay, this is the value 2, this is 16, we don't care, so we move forward. Again we are done with this interval. Now what is the next start point of this interval? This is 8 and this is 10 and this is 16. So again it doesn't matter, there is no overlap, so we can put this in the answer. Again this is 15, this is 13, this is 15, and this is 16. So again there is no overlap, so we can put this in the answer as well. And then we find out that after 15 there are no intervals, and we need to enter this new interval 16 and 17. So we simply add it over here from 16 to 17, and we add this to our array of answers as well, and we return these 4 as a new set of intervals. Now suppose somewhere in the rather than this one, these are like easy scenarios where we are given at the beginning or at the end. Suppose we are given something somewhere in the middle. So suppose we are given a new interval that we have to take care of, something like this, that it is from 5 to 7. This is the new interval that we are trying to insert. What should be the approach in this case? Again we are going to repeat the same case over here. This is the value 5 and 7. And now what we are going to do is we will start iterating over this given input. We will see that, okay, first value is 2, and the end of this interval is at 4. So this is 2 and 4, and the new interval starting point is 5. which means there is no conflict so far. So we would add this to our set of answers. Now from this 4 we reach at this 5, and at this 5 is the starting point of this new interval. So we check in our original set of intervals that from 5 to 7 does there exist any conflict. So from 5 to 7 actually there is no conflict in our original interval. So if there is no conflict, we simply add a new interval over here from 5 to 7, add it to our list of answers, and because we have reached the end of our new interval, right, we have reached the end of our new interval, which means what this dictates is that from this point forward there cannot be any existing interval that could be causing any sort of overlap with this with the arrival of this new interval. So whatever the answer or whatever the list of intervals we are given beyond this point, once we have already entered this new interval, we can simply add these to our answer array, and this would be our solution. So this would make our lives very easy, and that is how we would be able to handle this scenario as well, right? Now so far all the 3 scenarios we saw, we entered the value at the beginning, at the end, or somewhere in the middle, but in all the cases there was no conflict between existing intervals with the arrival of new intervals. Now suppose the new interval that we are trying to enter, that new interval is something like 3 to 8. Suppose it's something like this, that now we need to take care of this scenario where we are handling this new interval, and which is from 3 to 8. So what should be the approach in this case? Well, the approach is actually quite simple. We will start iterating over our input. We will find all the intervals. So first we find that what is the start point of this interval. So the start point of this interval is 2. And what is the end point of this interval? The end point of this interval is 4. Now what is and every time with the end interval, we are going to compare the start interval of the new interval that we are trying to insert. So the start interval of this one is 3 and this one is 4, which means that we know that we will have to enter this 3 over here, and there exists a conflict. Now since we have identified a conflicting scenario, what should be our approach? Well, our approach should be simple, that we are going to take a look at this particular interval, and we are going to take a look at this particular interval. Now there exists a conflict. Because there exists a conflict, we are going to check the starting points of both the intervals. Now in terms of starting points of both intervals, this one is smaller than this one. So whatever is the smaller, we are going to treat this as the starting point of this new interval that we are trying to enter, because there exists an overlap amongst these values. So we are taking care of the overlap. So that's why this would be our starting point. This would be the start of this new interval, and we are going to drag this new interval up until the end of this point. So up until the end of this point, when we come, we find out that it comes up until all the way to value number 8. Now in this scenario, we did not had anything in the middle, but if we did had anything in the middle, that would have been merged by this new interval, right? But the thing is, even when we come at this position number 8, we see that actually the position number 8 is start of another interval. So which is this one. So if it is start of this interval, we cannot just treat this as a separate interval. I mean, what I'm trying to say is we cannot have an interval like from 2 to 8 is one interval, and from 8 to 10 another interval, because this 8 is actually a conflicting point, and it is because it is a connecting point, these two intervals also needs to be merged. So because this 8 is a connecting point, we are going to merge this interval with this new interval that we are trying to create, and essentially this interval from 8 to 10 will also be dissolved by this new interval, and we would have an answer like this in this scenario, that we would have a newly created interval from 2 to 10. This would be for one interval where we have, and this would be another interval, because remember, now we have already entered this one, which means all the values beyond this point are not part of our concern. We can simply add it to our list. And in this scenario, the second interval would be from 13 to 15, and this would be our answer that we are going to return. So this is one conflicting scenario, and I mentioned that how we are going to tackle it. So essentially the different test cases in this case we can have is that we can either have a scenario where the item lies somewhere between beginning or at the end, where it is not conflicting with anyone. or it can be existing somewhere in the middle where it is not existing, not overlapping with any other interval, or it can be a case where it conflicts with some intervals, with one interval or more than one intervals. In either scenario, what we are going to do is, the moment we find that there exists a conflict, we are going to see that what is the start point, what is the lower value amongst these two. So because the lower value is 2, we are going to start this new interval starting from the position number 2. Okay, now for the end position, again we are going to do the same thing. We are going to check that what is the end position of this existing interval and what is the end position of this new interval, and in the end position we will have to check the maximum value, because the interval we are trying to create should be the size of biggest interval that we could create, which is not overlapping with any other interval. So that's why we would have an interval that is maximum amongst these two ending values. So these two ending values, the value is 8. So we would have an interval from 2 to 8 so far. But the thing is, this is not the end yet, because when we come at this 8, we will still have to check for the conflicting scenario. So over here we would have the starting, we would have two intervals like this, and in the two intervals we have the 8 value as the value number 8 as common. So we are going to merge these two as well, and in this case we are going to choose the biggest value we can find as 10, and we are actually, rather than having an interval from 2 to 8, we would actually have an interval from 2 to 10, and this is the critical part to understand. And this is basically our solution. Essentially we are using the greedy approach, but this is all, we don't need to do anything else. And if we calculate the time and space complexity, the time complexity in this case would be actually big O of n, because at any point for this new interval we would need to find that what should be the entry point of this new interval, and then we will check for the conflicting scenario. If there exists a conflict scenario, we will find a way to put it there. If there does not exist any conflicting scenario, well, good for us. In terms of space complexity, well, for the space complexity it would also be big O of n, because we will have to create a new array of list of intervals that we are going to return. So we will have to create a new two-dimensional array, something like this in this scenario, from where the answer would be 2 to 10 and 13 to 15. So this would be our new array that we are creating, and we would be returning that. So that's why that explains the space complexity. And yeah, this would be the solution. Now the question is, where can you use these kinds of approaches? Like, what is the point of having this question at the first place? And actually this is a very interesting question. It has a lot of practical applications. Practical applications is like, suppose you are trying to design an app where you need to maintain some sort of calendar, or you need to maintain scheduling. So these are very practical, very real life applications. Google Mail, Outlook, all the companies, they all use this mechanism. So if we know that where we need to insert an interval where we are not creating any conflict, it could be a conflict between shifts of 2 employees working for a factory, or it could be the interval between 2 trains going through a station. So like, yeah, these are real life practical examples, and that's why that justifies the number of companies that are asking this question. So first of all, we are going to initialize some variables, and we are going to create a new start and new end for the given new interval. We are also going to create two pointers, left and right, and left would be at the 0th position inside the given intervals, and right would be the last the size of the given intervals. We are also going to create a linked list to store all the output, and then we are going to convert it into the array. So now first of all, we are going to add all the non-overlapping intervals that come before the new start. So we are going to create a while loop. Okay, now inside our given list, we will need to add the new interval. So in order to add the new interval, we will have to check two conditions. There could be two possibilities. There might be an overlap, or there could not be an overlap. So we will have to take care of both of them. So first we are going to create a parameter called interval, and we are going to store all the value inside this parameter. Now we are going to check the condition that if the current position where we need to insert the new interval does there exist an overlap or not. So if there is no overlap, we can just simply add the new interval. So if that's the case, we can just simply add the new interval. If that is not the case, which means there exists an overlap. So if there is an overlap, we will have to first of all check that what entry we like, what should be the starting point and ending point of the overlapping character, and that we can define by choosing the minimum out of the starting values or the maximum out of ending values. So first of all, we are going to add the last value we have in our linked list inside this new interval variable that we created. And now we are going to check that what should be the endpoint, and we would add the new entry to our link list. Okay, now we might have to merge all the elements that are after that came because we added this new interval. So we will take care of the merge scenario. And if there exists an interval, we will do the same thing that we did before. So essentially we can just repeat this process. Yeah, after this loop runs, we should have everything stored inside the linked list, so we can return the linked list, but we will have to convert the linked list to an array. This should be our answer. Let's try to run the code. It seems like our solution is working. Let's try to submit this code. Oh, we will have to check for this end variable here, so that's why. Okay, looks like our solution is working, and it's actually pretty fast compared to a lot of other solutions. And even in terms of space complexity, we are also saving a lot of time, a lot of space as well. Hello friends, we are still not employed by a FAANG company, so let's not stop LeetCode until we get there. If there is any question that can get you in the FAANG, it's this one that we are going to solve today. Because if you just see that the number of companies that have asked this question, it's just out of this world. This question has been asked by hundreds of companies, literally hundreds of times. You can see over here that like Facebook and Amazon, they both have asked this question recently over 100 times in their interviews. So you can imagine the severity and the importance of this problem that we are going to solve. So apart from Facebook and Amazon, if we look at the number of companies that have asked this question, there are companies like Google, Salesforce, Microsoft, Bloomberg, Apple, Uber, LinkedIn, IBM, VMware, Walmart, TikTok, Adobe, Twitter, ByteDance, and then there are companies like Yahoo, PayPal, Wish, Goldman Sachs, Robinhood, and also Plantier, Square, and Netflix. So these are all one of my dream companies where I want to get a job. That's why I'm making these videos, and that's why I made this channel. So I would be paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem, and it is one of the most liked problems on LeetCode, and that's why a lot of companies likes to ask this problem. So essentially we are given an array of intervals where every single entry inside the interval mentions that there exists a start point and an end point of that particular interval. Now we need to iterate over all of the intervals, and then we will need to merge all the overlapping intervals. And we need to return an array of non-overlapping intervals from this given input, and that would be our solution. So if we try to understand this with an example, suppose we are given some set of intervals like this. Now let's try to mention them on this number sequence that we have drawn out. Now over here, our aim is to return all the non-overlapping intervals, and if there exists an overlap, we will need to merge those two intervals. So first of all, we will have to identify that what are those two intervals where we can see an overlap. So essentially, if we look at the start values of this interval, so the start value over here is 1 and 3. And if we look at the start value of this second interval, the start value is actually 2 and 6. And over here, we can clearly see that there exists an interval amongst these values. And these are the two intervals that are causing an overlap, and we will have to merge them. Now the question is, first of all, we need to know that why we were able to calculate that there exists an overlap over here based on the given input. Like this is a pictorial representation. We can clearly see that why there is an overlap. But in terms of computer, we will need to dictate some sort of mechanism. So essentially, we can say over here is that at any point, if we start iterating over any number of intervals, and if we identify that for those particular intervals, if the starting value, so in this case the starting value is actually 2, if this starting value falls between any interval, so because this 2 currently falls in between this 1 2 3, this first interval is 1 2 3, and over here the starting value of this new interval actually falls between those places. And the moment we identify that okay, this 2 falls between this 1 and 3 interval, so we know that okay, this interval that starts at 2, so this 2 to 6 is also causing an overlap between this given input interval, and we'll need to merge them. So this would be our condition to identify that at any moment, at any interval, we are trying to see that whether it intersects with some other interval or not. What we are going to check is we are going to see that suppose this value is the start value. So we are going to see that this start value, if that meets, if that is less, if that is greater than whatever the interval start we are checking and whatever the interval end we are checking for. If this condition is true, we can determine that there exists an overlap. And now since we have already identified that there is an overlap, we'll need to resolve that. So in order to resolve that, how we will resolve that is we will create an interval from this value number 1 to value number 6. So essentially we are merging both of these intervals. And what is the condition we are using to merge these two intervals is that we are going to check that okay, for the starting point of the new interval, what is the minimum value amongst both the start values. So in this case over here, the first start value is 1 and second start value is 2, so the minimum value is actually 1. So we create an interval that starts at position number 1, and for the end value there is this 3 and 6. So we compare this value 3 and we compare the value 6, and we identify that okay, 6 is greater in this case. So for the end value we are going to pick the maximum value amongst two values. So we are going to create a new interval like this, that is from 1 to 6, and then essentially we have taken care of these two overlapping intervals. And for this one, this 8 to 10 and this 15 to 18, these two intervals, they are not causing any kind of overlap, so we can just directly put them as it is inside our answer. So in this case, if we try to calculate that what would be our answer, the answer is actually quite simple. The our answer in this case is going to be an interval from 1 to 6, and this is the merge interval. Second interval is going to be 8 to 10, and the third interval is going to be 15 to 18. So this would be our solution, and we can simply return this one. Let's try to understand the same problem with another example that is given over here. So in the second example, we are only given two intervals, 1 to 4. So this is one interval, 1 to 4. So the question comes that are they overlapping integers? And the answer is yes. Why? Because if we see at this value number 4, actually 4 is connecting point for both the intervals. So 4 is the ending point for the interval 1, and it is the starting point for the interval number 2. So in this case, we actually need to merge these two intervals, and we will have to create an interval like this, that is from value number 1 to 5. And again, we are going to use the same logic. The logic is going to be that over here the values were 1 to 4, and over here the values were 4 to 5. So for the starting values, we are going to choose the lesser value, and for the ending values, we are going to pick the maximum value. So maximum value in the lesser value in this case is going to be 1, and maximum value is going to be 5. So this would be our intervals, and these are all the scenarios that we need to take care of. So suppose we are given a custom example like this. Let's see that what should be the solution. And always remember that it is really important for any programming interview that you come up with your own custom examples. It shows that you have the ability to think about all the different kinds of test cases, and you can come up with some unit test on your own. So over here our aim is to find that all the non-overlapping integers. Now to find all the non-overlapping integers, we already know that what is the condition, that how can we determine that any particular value is actually causing an overlap. And the way we can do it is that by checking the start value and comparing it with that whether it exists somewhere in between any given interval. The question is, previous two examples we saw, they were already sorted, so they were, all the starting values were already in a sorted manner, so that's why it was really easy for us to identify that whether there exists an overlap or not. But nowhere in the sequence we are told that all the input should be sorted, so that's why that makes things a little bit more complicated, and let's see that how it does so. So over here, suppose we are given an input 4 to 6. So we can create a line over here that, okay, there exists an interval like this from 4 to 6. Now second one is 11 to 15. So again, there is an input like this 11 to 15. Next one is 7 to 9. So there exists an input from 7 to 9. And this next input is 2 to 5. So we know that there is an overlap, but we are going to just draw it over here. And the next one is 13 to 16. So over here we can clearly see that there are two places where there exists an in overlap, but we don't know that yet, right? Because the input is not sorted and we will have to identify it by ourselves. So how we are going to actually identify? Well, essentially we are going to use the same logic. We are going to check that whether the start value falls in between any of the interval. If it does, we are going to determine that, okay, that part so if it does, so we know that this particular interval is in conflict with that interval, and then we are going to have to merge it. So let's try to do that. So over here we are comparing this value number 4, that is the starting value. First of all, we are going to check that whether 4 falls between 11 to 15. Well, it does not, so we are good with this. Whether 4 falls between 7 to 9, it does not, so we are good. But over here 4 actually falls between 2 to 5, because 2 is actually less than 4 and 4 is actually less than the 5. So we know that 4 actually exists over here, which means there exists a conflict between this and these two intervals. So we will have to resolve this conflict. How we are going to resolve this conflict? Well, of course, we are going to create a new interval. So starting value is going to be the lesser of both of them. So we are going to have a starting value that is at 2, and for the ending value it's going to be greater of both of them. So the ending value is going to be 6. So we are going to create a new interval like this, that is from this value number 2 to value number 6, and we are good with this one. So essentially we have merged these two intervals, so we can just simply mention that, okay, these two are merged or these two are taken care of, so we don't have to worry about them anymore. And now we are done with essentially these two intervals, right? And we have in our answer we already have this this new interval stored. Now let's see that how can we move forward. So again, for this 11 to 15, again we will have to repeat the same process. So we check that whether this 11 falls in between some interval. So first of all, we compare this 11 with this 4 and 6. So it does not fall in between. And also remember that because we are done over here doesn't mean that there could not be any more overlaps that we cannot take care of. So we might have to do it. So that's why we are going to compare again all the values. So 11 does not fall between 4 to 6, 11 does not fall between 7 to 9, 11 does not fall between this 2 to 5, and 11 does not fall between 13 to 16. So far we are good that, okay, this 11 to 15, that is okay, we don't have any issue with that. Now we again check for the 7 to 9. So we check that whether this 7 falls in between somewhere. So 7 does not fall over here, it does not fall over here, it does not fall over here, and it does not fall over here. So this 7 to 9 is also good. 2 to 5 we have already checked, okay. So this value number 2 does not fall anywhere, so we are good with this interval as well. Now again we are at this interval number 13. So for this interval number 13, it does not fall here, but it falls in this place. So we again have a conflict between this these two intervals. So 13 to 16, that is one interval, and second one interval is 11 to 15. There exists a conflict. So because there exists a conflict, we will have to resolve that, and we can mark these two as done. So we are going to create a new interval that is 11 and 16, which means lesser values of the starting values and greater values of the ending values, and this would be our new interval. So we can add this to our answer as well. So this would be 11 and 16. This is also our answer. And now we need to check that amongst these intervals, which were the ones that were not part of any overlapping series. So we know that this particular value 4 and 6 was part of an overlap, 2 and 5 was also part of an overlap, 11 15 and 13 16, they all were part of overlap, which we have taken care of with these two values. So this 7 and 9 was not part of any overlap, so we will have to add that to our answer as well, and we will add the 7 and 9 to our answer, and this would be our final answer in this case. Now the thing is, we are able to resolve this quite easily, right? We are able to generate the answer, we know all the logic and blah blah blah, we are able to identify the overlapping condition. If we calculate the time and space complexity in this case, the time complexity is actually big O of n square. Why n square? Because remember that for every single entity we are going to have to check all the remaining elements. Same goes for this one, that for every single entities we are going to have to check for all the other remaining values. So that causes n square work. The question is, can we do something better over here, and that rather than using this n square, can we bring down the time complexity? And the answer is yes. Okay, let's sort this given input. So the sorted result would be, now this is the sorted result. Now we need to identify that whether there exists a conflict or not. So it becomes really simple. What we are going to do is, we are always going to check the first value, and we are going to compare that whether the starting point of any value, if that is actually less than the ending point of the previous element. If that is the case, we would be able to identify that there exists a conflict. And always we are going to start checking from the second value, because for the first value we know that the first element is already the smallest value. So even if there exists a conflict between first two entities, this first one would always act as a starting point of the new merged variable, or the new merged interval. So let's try to do that, and over here we will start with the second position. We know that okay, this one is 4, we compare it with the last element of the previous interval. So last element of previous interval is 5, so we know that actually 4 is less than 5. In this case we know that there exists an overlap between these two values. Because there is an overlap, we can see that we need to take the minimum value amongst these two. So minimum value is actually 2, so we create a new interval starting at 2, and for the ending values we will have to check the last values. So the ending value in this case would be 6, so we will have a new interval like this. So let's draw a new interval like this on this number system. Now we are already done with these two values. Now we take a look at this value number 7. So again, for the 7 we compare with the last element in this case. So 7 is actually greater than 6, which means there does not exist a conflict between these two values. So we can start creating a new interval from 7. And now again, for this 11 we are going to compare it with the last element. So over here this value is 9, so 9 is actually less than 11, which means in this case there does not exist a conflict. So 7 to 9 is an interval in its own. We are good with this one. Now we have calculated this one. Now again, over here this is 13 and this is 15, so we know that 13 is actually less than 15. So in this case there exists a conflict between these two values. So because there exists a conflict, we are going to do the same conflict resolution technique. We are amongst this 11 and 13, we are going to pick the smaller value. So smaller value is going to be 11, so we pick this one. And for this 15 and 16 we are going to pick the greater value, so 16 is the greater value. So again we are going to create an interval like this, that is from 11 to 16. So essentially we have taken care of two overlaps that existed between these two values and these two values, but we were able to identify them immediately. Why? Because all we have to do is, at any point we just have to compare one value that was in the previous interval at any given moment. And now over here we can just simply start iterating over whatever the answer we have found so far. So in this case we can simply return the answer as 2 to 6, 7 to 9, and 11 to 16, and this would be our solution. Now if you look at the solution over here, essentially all we had to do is just iterate over the sorted input once. So basically, to generate this answer we are only doing big O of n work, but the total time complexity in this case is actually going to be big O of n log n. And why n log n? Because we will have to generate the sorted input from this given original input, and that takes n log n time. First of all, we are going to sort the given input. Okay, after sorting the given input based on this, based on their starting values, we are going to create a linked list, and we are going to store answer in this linked list. Now we are going to iterate every single interval inside the given input. So now we are going to check that whether we are at the first position, or whether the given interval, if that is in conflict or not. So if that is not in conflict, or there does not exist an overlap, we are simply going to add it to our answer. Okay, if that's not the case, we have detected a conflict, and the moment we detect a conflict, we will have to resolve the conflict. So essentially we are going to add the new interval that is merged. Okay, and after this loop ends, essentially our answer should be in the answer linked list, so we can return that. But in this case, we need to return a two-dimensional array, so we will convert our answer list to a 2D array. Okay, let's try to run this code. Seems like our solution is working. Let's try to submit this code. Okay, our solution works pretty efficiently. I would be posting this solution in the comments. You can check it out from there. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do non-overlapping intervals problem, and this problem is actually very similar to merge interval problems and insert interval problems. I have solved both of these problems, and I will be posting their links in the description so you can check it out from there. Like, though this problem seems like it has not been asked by many companies, actually this can be a very interesting post question after these two interview questions. So usually, like, all the interval problems, they are done in sync, and even for this particular problem, if we see, it has been asked by tech giants like Facebook, Amazon, Microsoft, Bloomberg, Apple, Oracle, Google, ByteDance, which is TikTok, and Snapchat, and these are my dream companies, so I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem, and we are basically given an array of intervals where every single entry has a starting point and an ending point that represents that particular interval. Now our aim is in this problem is that we need to return that how many minimum numbers of intervals that if we remove from this given original input, if we remove those, then the remaining result should be such that all the intervals becomes non-overlapping. So we need to return the number of intervals that we need to remove. So let's try to understand this problem with an example that is given over here. And over here we are given some set of intervals, and let's try to plot them on this given number series and see that what would be the answer. Okay, so after plotting all of these, our aim is to see that, okay, if there exists an overlap inside this given interval, we need to return the minimum number of intervals such that all the remaining intervals becomes non-overlapping. So over here we can clearly see that, okay, there exists an overlap between these points, and the overlap is actually mainly caused by because of this particular interval and these two intervals. So our aim is to remove the minimum number of intervals that that basically allows all the remaining intervals to become non-overlapping. So in this case, if we simply remove this particular interval that starts at position number 1 and ends at position number 3, this big one. So if we get rid of this particular big interval, we will have a result where all the intervals, they are actually not in collision with each other and they are not overlapping with each other. Over here we can see that they actually connect at some point, but that is not an overlap. Like, I know that in previous questions we used to consider this as an overlap, but you can confirm this with your interviewer that with what approach they want to go. So in this case, we only get rid of this one interval that was existing, and because we get rid of one, we will return one. That in this given input, if we simply remove one interval, we can determine that, okay, there exists one interval such that if we remove that, then all the other intervals becomes non-overlapping. Now to generate the optimal solution, the main thing is that we will have to determine that whether there exists an overlap inside the given interval or not. Now, in the previous examples we saw, the input was already sorted, but in the problem statement it is nowhere written that the input should be sorted. So input could be something like this, where everything is different value. Now the thing is, first of all, over here we need to determine that what are the intervals that are actually causing the overlap, and then we can determine that which one should be removed and what not, blah blah blah, what should be the strategy for that. Now the thing is, if we plot these this given input on side on a number system, we will get a result like this. Over here we can clearly see that there exists a conflict between these two intervals, which is represented over here. The thing is, how we were able to identify that there exists a conflict. We were able to identify it because the starting point of this particular interval was actually falling between the two values of some already existing interval. So that is the condition we will have to determine if we want to find that whether there exists an overlap or not. So over here, suppose we get at value number 5, and we want to check that whether 5 has an overlap anywhere. So 5, we will have to check all the other intervals. So 5 does not exist between this 2 to 4, so there is no overlap with this one. It also does not exist between 8 to 9, so there is no overlap, and it does not exist between 1 and 3, so that's why there is no overlap. So now we are say that okay, this 5 7 has no overlap with any other interval. Now we check for this value number 2 to 4. So again we check the starting point for the value number 2. So value number 2 does not fall between 8 to 9, so there is no overlap. But 2 actually falls between this 1 to 3, because 1 is actually less than the value 2 and 2 is actually less than the value number 3. So which means 2 falls between this interval. So that's why the interval 2 to 4 and 1 to 3 are in between an overlap, and then we will have to take care of that scenario. Now, do you see a problem with this one? And the problem is that I can see is that for every single value, we will have to check all the other remaining values, that whether there exists an overlap or not. And that actually causes big O of n square time. And this is unnecessary work. Like, even just to determine that whether there exists an overlap or not, we are actually doing big O of n square work, which is like pointless. There exists a better approach, and the better approach is that if we sort the given input and then we sort them based on their starting values, things becomes a lot easier. So let's see that what should be the sorted array. Now we have sorted this given original set of intervals, and now we have all the values sorted. So now if we want to identify that whether there exists an overlap, all we need to do is we just need to compare any two adjacent values, and the moment we compare any two adjacent values, we can directly tell that whether there exists a conflict between them or not. How can we tell them is that we only need to check that whether the starting point of any second interval compared to its previous interval, if that is smaller, then we know that there exists a conflict. So in this case, we can say that between this 1 and 3 and 2 and 4, there exists a conflict because this particular interval ends at value number 3 and this particular interval starts at value number 2. So that's why there is a conflict. Meanwhile, if we see over here, this particular interval ends at value number 4 and this one starts at value number 5. So that's why there is no conflict. So this is a very easy way for us to determine that whether there exists a conflict or not. And if we see in terms of time complexity, the time complexity for the sorted operation takes only big O of n log n, which is a big improvement compared to the previous time complexity for this one, which was big O of n square. Okay, now we have determined that how to identify overlap. The question is that how to find that what should be the most number of nodes that we will have to remove, and what should be the strategy for it. So essentially there can be 3 different scenarios at any given moment. The first scenario is that between two intervals there does not exist an overlap. So if there does not exist an overlap, there is no need for removal. So we don't need to remove at anything. So we are good in this case. This is like the most beautiful thing. The second scenario is that we are given one interval that is clearly bigger compared to the second interval. So essentially we can say that this second interval is actually subset of this given bigger interval. So in this case, things actually becomes pretty easy for us. All we need to do is that we simply need to remove the bigger interval, because there is a conflict between these two intervals right now, which we can see, but there could be possibility that there might exist some other interval, something like this. So say in this scenario, if we got rid of this interval, we still have to we will still find ourselves to be having conflict between these two intervals, and again in order to resolve that we will have to remove this one as well. But rather doing this, suppose in this scenario we only had two intervals like this, and originally if we just got rid of this bigger interval, then immediately, even though there exists another interval somewhere down which was actually causing an overlap between this original interval, still we will have to perform less remove operations. So that is why the strategy should be that always remove the bigger interval. Now the question comes in scenario like this, where the starting point of one interval is actually falling before and the starting point of second interval actually falls somewhere in between. So what should be our approach in this scenario? And in this scenario as well, what I'm suggesting is that we remove the interval that has the longer end point. Essentially, if we at any point identifies ourselves in this kind of scenario, our strategy should be to remove the interval with the end point that is greater. So suppose we consider that the starting point for this interval is actually 1 2 3, and suppose we consider that starting point for this interval is 2 to 4. So in this scenario, the strategy we are going to use is that we are always going to remove the interval 2 to 4. Why? Because we are going to compare the end values, and whichever interval has the greater end value, we will decide to remove that particular interval. So essentially we are using a greedy approach. But by using this greedy approach, what we are going to do is that over here we know that for this particular case, for this particular interval, we only had an interval that was causing an overlap over here. But again, the same thing could happen, that we might have another interval like this, where this particular interval was causing an overlap between this and also this. So immediately remember, our input is sorted, so we are coming from left to right inside the number sequence. So the moment we identify that whatever has the greater end point, if we decide to remove that, so even over here we already got rid of this one. So even over here, if there exists another interval that comes after this 1 2 3, still it would not be in overlap with this 1 2 3, and we will have to do less remove operation. And this would be our ideal approach. If we calculate the time and space complexity, basically the time complexity in this case is going to be big O of n log n. And why n log n? Essentially, doing this interval, converting this interval from normal input to sorted input takes n log n time. And then after that, once we have this input given, essentially all we need to do is just we have to iterate over the given input once, because it is already sorted, and then we can perform the remove operation and we can count the number of times we removed any interval. So that this second part takes big O of n time. So total work we are doing is actually big O of n log n plus big O of n, but in general we can write this as big O of n log n. And in terms of space complexity, we are not using anything extra, so we can just say that it's a constant time space complexity. At most we are just going to use couple of extra variables. So first of all, we are going to check that if the given intervals is empty, so we are going to return 0. Okay, if that's not the case, we will have to sort the given input, and we are going to sort the given input based on the starting values. Okay, after the sorting, we are going to initialize couple of variables. So we are going to keep a variable called previous to keep track of the previous element, and we will initialize it to 0. We are also going to have a variable called count to keep track of the number of elements that we will have to remove. So we are also going to initialize it to 0. And now we are going to run a for loop that runs over the given sorted input. And over here we are going to start it as int I is equal to 1, because we already have the previous value as 0 for the comparison. And remember that because the input is sorted, at any given moment we are only comparing two adjacent elements inside the given interval. So first of all, we are going to check that if there exists an overlap between two adjacent elements, and if there exists an overlap, we are going to check that which element is having the greater end value. So we will update the previous counter based on that, and if there exists an overlap, we are going to increase our count. This second if condition dictates that if the previous interval is actually greater than the current interval we are at, we will have to update the previous counter to next element, and in any case we are going to increment our count variable. And if this is not the case, essentially we have found that between two adjacent intervals there does not exist any overlap, so we are going to increase our value of our previous previous variable to the current I, so that we can use it for further implementation. And once we are done with this loop, essentially this count variable should have our answer, so we can simply return the count variable, and this should be our solution. Let's try to run the code. Okay, seems like our solution is working. Let's try to submit the code. Okay, our solution is working as expected, and it's actually pretty efficient in terms of memory usage, and even in terms of time complexity it's not that bad compared to other solutions. I would be posting this in the comments and you can check it out from there. We are not gonna stop till we get in. Hello friends, we are still not employed by a FAANG company, so let's not stop LeetCoding till we get there. Today we are going to do meeting rooms LeetCode problem, and this is actually a LeetCode premium problem. So if you want to know that what are the list of companies that have asked this question in their interviews, that comes later in the video, and I have provided the timestamp for that, so you can directly go and check it out. Let's understand the problem statement. Essentially, we are given an array of meetings called intervals, and we are given start time and an end time for every single meetings inside this given array. Now we need to determine that if one person can attend all the meetings or not. So let's try to understand this given problem by an example. So over here we are given 3 different meeting times, and let's try to plot them on this number sequence that we have created. So first meeting starts from 0 time and it lasts until 30 minutes. Second meeting starts at 5 minutes and ends at 10 minutes, and third meeting starts at 15 minutes and ends at 20 minutes. So over here we can clearly see that there is no way possible for one person to attend all the meetings, because there exists a conflict between this meeting and this meeting, and there also exists a conflict between this meeting and this meeting and this meeting. So because there is an overlap between intervals, and essentially that's what we will have to determine in this problem. So over here we can clearly return false, that there does not exist any way possible for one person to attend all the different meetings that are given in this interval. Now if we take a look at the second example, and let's try to plot it in on a number sequence. So over here we can imagine a number sequence like this, and over here we are given one meeting that starts at 7 and ends at value number 10, and second meeting starts at 2 and ends at value number 4. So over here we can clearly see that it's possible for one person to attend this meeting, and after that he can attend he or she can attend this meeting. So in this case we will return true, and basically that's what we will need to determine. Now the tricky part over here is that we will have to determine that how do we identify that there exists overlap between any two values. So suppose over here in this example, if we are given an another meeting that starts at 3 and ends at 5, something like that. Now in this case, can we say that can one person attend all the meetings or not? Well, we can clearly see that because there is an overlap between these two meetings, one person won't be able to attend all 3 meetings, and over here we will have to return false. The thing is, why we were able to determine that over here there exists an overlap. So because over here we see that the starting point for this meeting and ending point for this meeting is from 2 to 4, so that is one interval. And if we look at this one, the starting point from this for this one and this ending point for this one is 3 to 5, so this is 3 to 5. So over here if we consider this particular interval, we can see that the starting point of this interval actually falls somewhere between any other interval that already exists. So at any moment, if we determine that the starting point of some interval, if it falls between any interval and this condition is satisfied, that 2 is actually less than 3 and 3 is actually less than 4, which means 3 falls in between this interval. So that's why we can determine that there exists an overlap, and the moment we identify that there is an overlap over here, we will immediately return false, and this is how we are going to approach. Suppose we are given an input like this. The different intervals are given, and this is the number sequence that we are going to use. Now over here, essentially, if we want to determine that can one person attend all the meetings, we will have to check that whether there exists a conflict or not. So if we look at this first scenario, previously we determined that how to identify an overlap. So if we look at the starting value of this 20, we will have to check that whether this 20 exists in between some intervals. So over here, this is 10 to 15. So 20 does not exist over here. This is 35 to 45. So 20 does not exist over here. And this is 10 to 20. Now this meeting ends at 20 and this meeting starts at 20. So this is also a legitimate scenario because 20 is not part of this interval. So that is why we can determine that, okay, this meeting is good, like the starting point does not have a conflict with any other meetings. Now let's see about this one. So this meeting is from 0 to 15, right? So does there exist any conflict between these two, between this 0? So 0 does not exist between this one. 0 also does not exist over here, and 0 does not exist over here. So we are good. Same goes for this 35, that 35 does not exist between these two, this one or this one. So we are good. But when we come to this value number 10, we can clearly see that this 10 actually falls between this 0 to 15 because this condition is satisfied. 0 is less than 10 and 10 is less than 15. So over here we can clearly see that there exists an overlap between these two elements, and we can immediately return false. So this approach would work perfectly fine. But what is the issue with this approach? The issue is that this takes big O of n square time. Why big O of n square time? Because remember, for every single element, we will have to check all the remaining elements based on the starting point. Same goes for this one, same goes for this one. So that's why we are doing n square work. So this work can greatly reduce if we just sort the given input based on the meeting start times. And let me show you how. So let me clean this up and let me sort this given input. So now we have the sorted input. Now in the sorted input, if you take a look at it, we are actually able to determine that whether there exists an overlap immediately. How? All we need to do is we'll need to compare the starting point with the ending point of the previous interval. If the starting point is actually less than the ending point of previous interval, we can determine that this meeting actually starts before the previous meeting ends, and immediately we can identify that whether there exists an overlap or not. So this is basically our solution. Like in this scenario, we can clearly see that the moment we are in the meeting from 0 to 15, so there is a meeting going on from 0 to 15, and before this meeting ends, there is another meeting that starts at 10 and lasts up until 20-minute mark. So there is an overlap over here, and immediately we will return false in this case. So this approach actually works, and it is more efficient than the previous approach we suggested. Why it is more efficient? Because if we calculate the time complexity in this case is going to be big O of n log n for the sorting operation, because from this given input, first of all, we will have to create a sorted input, and once we are done with that, if we want to identify the overlap, we only need to check any two adjacent values at any given moment, and the moment we reach to the end point and we don't find any issues, we can return true, or if we find any issue, we can return false before that. So this takes big O of n time. So total time complexity can be considered as big O of n log n. And in terms of space complexity, we are not using any additional space, so we can say that we are only using constant time to run this problem. And this is the final approach. Now let me show you the list of companies that have asked this problem, and if you are not interested, you can directly go to coding. So essentially, companies like Amazon, Google, Facebook, they have all asked this problem recently, and Microsoft and Wayfair, they are also really popular, well-paying companies that have asked this problem. Also companies like Bloomberg, Adobe, and eBay, that one of my dream companies that I want to join in, apart from the original, these tech giants. So first of all, we are going to sort the given input based on the start times of the given intervals. After sorting, we will have to iterate over all the sorted intervals, and we are going to check that whether there exists an overlap or not. We are going to check that whether the end point of any meeting is greater than the starting point of next meeting. If that is the case, we are going to return false immediately. And if this loop ends and we are able to reach to the last element, we are going to return true, that there does not exist an overlap. And now let's try to run this code. Okay, seems like our code is working. Let's try to submit the code. Okay, our submission works, and the code is actually pretty efficient, and I would be posting this in the comments. It is not too many lines of code, and this problem is very similar to the previous 3 interval problems that we have done. So I would be posting them in the comments. You can check it out from there. Hello friends, we are still not employed by a FAANG company, so let's not stop LeetCode until we get there. Today we are going to do a LeetCode premium problem, and you can clearly see that this has been one of the most popular LeetCode premium problems. This has been asked in companies like Amazon, Facebook, Google, Bloomberg, Microsoft, Oracle, Walmart, Uber, Twitter, Apple, Goldman Sachs, TikTok, and ByteDance, and also some other companies like eBay, Adobe, Swiggy. They all have also asked this question fairly recently. So my aim, you all know that I want to get a job at any top tier FAANG company, and that's why I'm making these videos. So I'm paying my utmost attention, and I hope you also enjoy the video. LeetCode medium problem, and it is one of the most popular problems on LeetCode. If you see the like to dislike ratio, also the name is meeting rooms 2, so basically it is the next version of the original problem meeting rooms that I have already solved over here, so you can check it out from there. Now in this given problem, we are basically given an array of meeting times called intervals, and we are given a start value and an end value, and obviously start value is always going to come before the end value, like as it should be. Now we need to say that based on the given number of meetings, how many number of minimum conference rooms we are required so that all the meetings can be accommodated. And we know that for any single meeting we need at least one conference room, and when that meeting ends, that conference room can be used for some other meeting. So suppose say for example, we have a meeting that starts at 5 and ends at 15 minutes, and we have another meeting that starts at, let's say, 17 minutes and ends at 27 minutes, something like that. So in this case, if we only have one conference room, we are still good. Why? Because first of all, this meeting will take place, all the attendees will attend this meeting. At 15 this meeting is going to end, and then they are going to leave away from this meeting, and then these new people are going to attend the meeting in the same conference room. So in this case, we can clearly determine that, okay, with one conference room we are sufficient to complete all the meetings. Now but problem comes when, say for example, we have a meeting that starts at 0 and ends at 30 minutes. I'm using this original example that is given. So suppose we have a meeting that starts at 0 minute and ends at 30 minutes. We have another meeting that, let's say, starts at 5 minutes and ends at 10 minutes, and we have another meeting that, let's say, starts at 15 minutes and end at 20 minutes. So something like that. So essentially over here we are having 3 different meetings, and now for these 3 meetings, how many minimum number of rooms we need to accommodate all the meetings. So clearly we can see that essentially there exists an overlap between this meeting and this meeting. There also exists an overlap between this meeting and this meeting. So because there exists an overlap, that is causing us to have more than one rooms, because at any given moment two meetings are happening at the same time, but they cannot be placed in one conference rooms. So now we will have to determine that how many number of conference room we need. Well, we will need, in this case, we will need 2 conference rooms. Why 2 conference rooms? If we look at this start time and end time for all the meetings, initially, let's say we have a conference room like this. So initially this first meeting takes place, which starts at this 0 minute, right? So let's say that, okay, this meeting is being taken place over here. Now when we reach at this time number 5, we know that another meeting also needs to be started, but this conference room is also already occupied, so we cannot use this conference room. So what we will have to do is we will have to use another conference room, and let me draw it over here. So we will have to use another conference room to accommodate this meeting over here. Now at this time number 5, we started the meeting, but we noticed that at value number 10, we also finished this meeting, which means that now all the folks that attended this meeting, they are actually coming out of the conference room, and now this conference room is empty, but this conference room is still occupied with this original ongoing meeting. So that we will have to take care of. So at value number 10, we already emptied this conference room, but again we start seeing in this order. So we can find that at time number 15, we still need one more conference room to attend the meeting. So we check, okay, this conference room is already occupied, so we can't do anything. But this conference room is empty because this meeting has already been completed, which means we don't have to worry about it. So this meeting that starts at time number 15 needs to be placed on this second conference room again, and then it ends at minute number 20. So at 20 minutes, all the folks, they empty this conference room. So again, this conference room is now empty. Now there is no one, but this meeting is still going on. And when the clock hits 30 minutes, we can see that, okay, now this particular conference room, the first conference room, is also going to be empty, and folks are going to leave it at time number 30. And this is basically the approach. So at any given moment, the maximum number of conference rooms we were using to accommodate all the meetings were actually 2. So in this case, we will need to return 2 as our answer. The question comes that why we were able to generate this 2, why not some other value, and how do we programmatically solve this problem? Well, the approach is actually quite simple. That over here, what we needed is only two things. The first thing we needed is that at any point, what was the start point, what is the end point, and based on the start and end points, we can actually come up with some very interesting results. So if we see over here in this example, what we were doing is that at any given moment, we are iterating over this time sequence, and based on the starting point of the meeting and ending point of the meeting, we are either occupying the room or we are emptying the room. And just by keeping track of those two activities, we can determine that what is the minimum number of rooms that we need in order for us to accommodate all the meetings. Let me show you how. So over here, again, keeping up with the same example. So let's say that in this example, we already have the start and end times of all of them. So what we can do is we can have 2 arrays. So first array would be for starting values, and second array would be for ending values. And we are going to sort both the arrays based on the timing. So over here, the sorting values would be that what are the starting points? Starting points we have over here is 0, 5 and 15. So we have 3 starting points originally, and over here you can see that they are in sorted order, but if you look at the original input, we can't see them in sorted order. Like they can be jumbled up, or the values can be given in any order, right? So first of all, we will sort everything, and then that sorting is going to take big O of n log n time. So that is some activity that we will discuss when we come to the time and space complexity. So initially the sorting position, currently this value is 0, 5 and 15. Okay, let me get rid of this extra space. Okay, now for the ending values are 10, 20 and 30. So again, let's sort based on the ending values. So 10, 20 and 30. And now what we are going to do is, at any given moment, we are going to check both of these arrays, and amongst these two arrays, we are going to see that what is the minimum value amongst either starting value or ending value, and we are going to keep a count or keep a variable called meetings, and we are going to increase the value based on whatever the results we find over here. So let's try to do that. So initially we compare these two values. We see that okay, 0 is minimum amongst these two. So because we are starting a new meeting, which means we will have to occupy a room, and because we have to occupy a room, what we are going to do is we are going to do meeting plus plus. So essentially the value of meeting was originally 0, so we are going to keep the value as 1. Now we are keeping the value as 1. What we are going to do is we are going to iterate over. So this we are keeping at this because this has not been updated in the ending value, but in the starting value the 0 has already been taken care of, so we ignore this case. And now for the starting value we compare this value number 5. So again we compare this value number 5 with this value number 10. We see that okay, the smaller value amongst these two is still the starting point in the starting array, and because we are starting a new meeting, which means that we haven't completed any meeting but we are starting a new meeting. So because we are starting a new meeting, we'll still have to add the value of meeting. So currently the number of conference rooms we will need, we are going to increase it to 2. And by the way, this you can call it, consider as meeting rooms. I just named it meeting just for simplicity. Okay, now again we are done with this 5. So again for the start value we increment, and over here we are still at this position number 10. Again we compare this 15 and 10. So over here we realize that this 10 is actually smaller than 15, which means we are ending a meeting before. So now because we are ending the meeting, so we will jump on this ending array. Now we will come to this place, and because we ended a meeting, which means we will have to subtract the value over here. So what we are going to do is, rather than having 2, we will reduce this value back to 1. And so now we are at this 15 and 20. So we compare both the values and we realize that okay, this 15 comes first, so we are starting a meeting now. So because we are starting a meeting, will again do plus plus. So now this 1 becomes 2, and we compare this meeting with this answer. So both values are 2, so we don't need to update anything. And that's why over here we are done with this case. So now there is no more place to start the meetings. So actually we can end over here. Why? Because over here the moment we are going to like reach this and this value, all we are going to do is we are simply going to reduce the value of this meeting parameter back to 1 and then again back to 0. So there is no point in us for doing all this work if the starting array has already been dealt with, and this would be our solution. Like this is a very simple solution to understand and easy to come up with, and this is also very optimal and it solves the problem efficiently. So let's see that what would be the time and space complexity. The time complexity in this case is going to be big O of n log n. So this is initially for sorting, as I mentioned earlier, plus big O of n, and this big O of n is to iterate over the start and end array. So in general we can write this as big O of n log n only. And now we are done with this one. In terms of space complexity, for the space complexity it would be big O of 2n, because we are storing 2 arrays, and in the both arrays we are storing some n values. So but in general we can write this as big O of n as well, and this would be the optimal time and space complexity. First of all, we are going to check that if the given array of intervals is empty or not. If it is empty, we are going to return 0. That is not the case. We are going to create 2 integer arrays, start and end, and for both the arrays we are actually going to fill out all the values in the start array and end array. Once that is done, we are going to iterate over the given input, and from the given intervals we are going to fill out the start and end array. Once this is done, we are going to sort the given start and end array. And once sorting is done, we are going to initialize a couple of pointers. So we are going to name them a start pointer and an end pointer, and we are going to initialize the values as 0, and these pointers are going to be used to iterate over this start and end array. And once these two are done, we are also going to have a variable called result to keep track of the number of meeting rooms that are needed, and we are also going to initialize that to 0. And now we are going to run a loop, but remember that we only need to run a loop until the start array has some values. So we are only going to iterate over the start array, because once start array is done, the result value is always gonna go down. And at any point we are going to check that whether the current start value is actually greater than or equal to the end value or not. If that is the case, we will have to update the end array. And the reason we are doing it is, suppose we are given a couple of arrays like this, that a meeting starts at 0 and ends at 10 minutes, and there is another meeting that starts at 10 and ends at 15. So in this case, we can actually use just one room or one conference room to iterate over. Why? Because first meeting has to end first before the second meeting starts. This is a condition that is given, and we are going to use that. Hence, if this is the case, we are going to decrement the number of result that is, and we are going to increment the end pointer. And if that is not the case, so which means that we essentially have a meeting starting before the previous meeting ending, and in that case we will always have to increase the number of rooms needed. So we can simply increase the result, and we will also have to update the starting pointer. And at the end, once this loop is done, we can simply return whatever the result we found. Let's try to run this code. Seems like our solution is working. Let's try to submit this code. And we are actually solving this problem way faster than a lot of other Java solutions, and you can see it over here. So I would be posting this code in the solution in the comments. You can check it out from there.